in the opener here, we kind of used some ideas that we already knew. Mainly the rules that we have for solving equations, along with the idea that a square and a square root cancel each other out to solve an equation with the square root in it. Today we're going to do more equations like that. Before we get going, I'm going to have you go ahead and just write down the steps that we're going to take. There's one more thing we're going to do to set up equations that have square roots in them, which is this first thing here. We're going to box the square root. So in addition to circling the variable and drawing the line of equality, we're also going to put a box around the square root. That's going to be a reminder of something that we'll talk about later. And then we're going to use the golden rule to get that square root by itself. Once the square root's by itself, we have to get rid of it. What do we use to get rid of a square root? What do we use in the opener?
Squares.
We use a square, right? So once we have the square root by itself, we're going to use a square to get rid of the square root. Okay, so we square both sides of the equation. We square one side to get rid of a square root and the other side because of the golden rule. Once we get rid of the square root, okay, so that purpose of step 2 of squaring both sides is to get rid of the square root. Once we get rid of the square root, we just solve like we normally do. Here's your first example. Go ahead and write it down under example 1. So we've got a problem with the square root in it. This one looks a little different than what we did in the opener, right? But same idea. We have a variable that we're trying to get by itself, and we have a square root in there. All right, so one of the biggest differences between this and the one we did in the opener is this plus 2 is inside the square root, right? That's going to affect how we do this. So let's start by setting this up like we normally do. So we always do what 2 things? Circle the variable and draw the line of equality. Now there's one more thing that we're going to have you do. All right, what did step 1 say? Box the square root. So what we're going to do is we're going to look for the square root, and we're going to put a box around the square root, and that includes everything that's inside of the square root. The reason we do that has to do with step 2 and getting rid of the square root. We can't get rid of the square root if we have anything with it that's not in the square root. All right, in this problem, though, is there anything over here on the left side of the equation that's not in the square root? No. All right, so we've actually already got step 1 done, which is to get the square root by itself. So the next thing I need to do, before I can start getting rid of things that are inside of the square root, is I have to get rid of the square root. How do we get rid of the square root? What are we going to use?
Squares.
We're going to use a square, exactly. All right, so to get rid of this square root, we're going to use a square. Remember, a square or an exponent always goes up and to the right. Okay, so we put the square up and to the right of the square root, which means that we have to do what? If we square the left side, then we also have to square the right side. So for this 5, I'm going to go up and to the right and put my square on there. What happens with the square and the square root now? They cancel each other out. So the square and the square root, those both go away, which leaves what on the left side? C plus 2. All right, so when we get rid of that square root, everything that was in the square root comes down, but the square root's gone now, right? On the on the right side, how do we simplify the 5 squared? 5 times 5, which is 25. All right, now I'm missing one thing here to finish up this step. Need an equal sign on the line of equality. All right, now we just solve like we normally do. So I need to get rid of the plus 2 to get the c by itself. What am I going to do? Subtract 2. The 2's on the left are going to cancel each other out, leaving what? C. On the right side, what's 25 minus 2? 23. Equal sign on the line. Box your answer. I'm not asking you to do this yet. We'll practice this later in the week. But what we could do now is we could plug that 23 into the equation and make sure it works. So you don't need to write this on the paper, but I just want to show you what that would look like. So we're going to have the square root of, instead of c plus 2, we're going to have 23 plus 2, and then equals 5. We simplify the radicand, the inside of the square root. 23 plus 2 is 25, but the square root's still there, and the square root of 25 is 5. Okay, so doing that confirms that we had the right answer because we get the same thing on both sides. All right, again, we'll be doing that later. We don't need to worry about that just yet. All right, so this equation right here is really similar. I want you to try this one on your own. All right, make sure you set it up, circle a variable, draw the line, box your square. Your square root, and then solve. Again, in addition to circling the variable and drawing the line of equality, we're always going to box the square root and anything that's inside of the square root. Okay, again, that's a reminder that we have to get rid of anything that's not part of the square root before we can get rid of it. Now, the thing is, in this problem, is there anything that's outside of the square root over here on the left side?
No.
No. So we can go straight to step 2, which says get rid of the square root. How do we get rid of the square root? Square it. Okay, so square goes up and to the right. And if I square the left side, I need to square the right side.
Oh, I messed it up. I forgot.
Okay, so once I square both sides, I'm going to simplify. On the left side, when I simplify, what's going to happen? The square and the square root cancel each other out. Those go away, and what does that leave? E plus 14. On the right side, 2 squared means 2 times 2, right? Which is 4. Equal sign goes on the line. Now we just solve like we normally do. What are we going to do to get E by itself? Subtract 14. Subtract 14. On the left side, those 14s cancel, leaving what? E. And on the right side, 4 minus 14 is? Negative 10. Equal sign goes on the line. Box your answer. This problem is different because we've got stuff on the outside of the square root and stuff on the inside. So the first thing I want to say about this, while you're writing it down, make sure the plus 1 is under the square root. Make sure the minus 3 is not. All right, so when we set it up, we're going to circle the variable. We're going to draw that line of equality. And what else are we going to do? Box the square root. Is my box going to look like this?
No.
What's wrong with that?
This 3 is not in the square root.
Yeah, the 3 is not inside the square root, so it shouldn't be inside my box. So my box is around the square root and what's in the square root, and that's it. So that minus 3 is outside the box. All right, here's where that box comes into play. That tells me that I need to get rid of what first? I need to get rid of the 3. I need to get rid of anything that's outside the box to start with. All right, so I'm not going to get rid of the square root yet. I'm not using my square yet. I need to get rid of that minus 3. How do I do that? Add 3. So we're going to add 3 on the left, add 3 on the right. On the left side, those 3's cancel each other out. When those go away, what does that leave? Is it just D plus 1? Yeah, we need the square root still, right? We haven't gotten rid of it yet. And then on the right side, 6 plus 3 is 9. Equal sign on the line, right? Okay, is there anything else outside the square root that we need to get rid of? Well, everything's gone on the outside of the square root, which means it's time to get rid of the square root. Okay, so everything's gone outside. Now we need to get rid of it. How do we get rid of the square root? A square. So up and to the right, we put our square. So on the right side, we also have to square it, up and to the right. I'll tell you right now, we're going to take a point off on your quiz or on the final if you put your square up and to the left or if you put it down and to the right. All right, it doesn't mean the same thing. When we do that, the square and the square root cancel, right? What does that leave when those go away? D plus 1. And on the right side, 9 squared is 9 times 9? 81. Now what? Subtract 1. So we're just solving like we normally do now, right? 1's cancel, we get D equals 80. And again, you don't need to do this, but we could put the 80 back in here. So we would have inside the square root 80 plus 1, which is 81. Take the square root of that, we get 9, and then 9 minus 3 gives us 6, so it checks out. To set it up, we're going to circle the variable, draw the line of equality, and one more thing. Box the square root. Now notice that when I box the square root, I'm just boxing the top of the fraction. That 2 is not inside the fraction, inside the square root, so we don't box it. All right, what that box tells me is I need to get rid of everything outside the box first. What's outside the box that I need to get rid of? The 2. And how do I get rid of that 2? Multiply. So we're going to multiply by 2, which means we multiply by 2. Notice that we're not squaring yet. We're not getting rid of the square root because the square root's not by itself. All right, on the left side, those 2's cancel. What does that leave? The square root of f minus 3. On the right side, what's 3 times 2? 6. Equal sign on the line. Is there anything else outside the square root that we need to get rid of? No, so what's it time for? It's time for the square to get rid of the square root, right? Once we get rid of everything outside the square root, now we get rid of the square root. And how do we get rid of it? Square. Got to square both sides. Cancel the square and the square root on the left. What does that leave? F minus 3. On the right side, 6 squared is equal sign on the line, and we're done, right? No, we still have to get f by itself. What do we do? Add 3, add 3. 3's on the left cancel. That leaves what? F. On the right side, 36 plus 3 is 39.